So next we're going to be proving Newton's method. So once again, the goal of Newton's method is to find this x-intercept when the function itself is hard to solve for or impossible to solve for. So what I'm going to do first is guess, and I'm going to make that first guess x sub 1. And again, I'm going to be looking for the equation of the tangent line and finding the x-intercept for that. So the first thing I'm going to need is the equation of this tangent line at x sub 1. And I'm going to use the point slope form. Point slope tells me y minus y1, which is going to be the output here, which is f of x sub 1. F of x sub 1 is equal to the slope, which is f prime at x sub 1, times x minus x sub 1. Okay? So that's the equation, the general equation of this line. Now what I'm going to do next is I'm going to solve for the x-intercept by plugging in 0 for y. And if I plug in for 0 for y, this x value is now going to become the x-intercept of x sub 2. And what I'm going to do next is solve for this x sub 2. So I'm going to distribute this in. So f prime of x sub 1 times x sub 2 minus f prime of x sub 1 times x sub 1. Again, this is what I'm solving for. So to get that by itself, I'm going to add f prime of x sub 1, this term, over to the other side, minus this term, all over f prime of x sub 1. I'm going to simplify it by distributing the division. These terms will cancel. I'll be left with x sub 1 minus f of x sub 1 all over f prime of x sub 1. And this will give me x sub 2. Now what I do next with my x sub 2 here is I'm going to plug that in and now use that as my guess and find the equation of this tangent line here, which, as you can see, it gets closer and it'll give me x sub 3, a next guess of x sub 3. Now what will be x sub 3? Well, I just found x sub 2 here. And it's going to go through the exact same process, where I use x sub 2 instead of x sub 1. Therefore, my x sub 3 is going to look exactly the same way as this, except I would have plugged in x sub 2. All over f prime of x sub 2. Okay? So what this actually does is it actually gives you a formula which is known as Newton's method. It tells me x sub n is going to equal to x sub n minus 1 minus f of x sub n minus 1 all over f prime of x sub n minus 1. And this will be our Newton's method. So let's try an example next. This example, starting with x sub 1 is equal to 2, so I'm going to make that my first guess. Find the third approximation, x sub 3, to the root of this equation here. Now the very first thing we have to do is figure out what the function is. Well, the function, I'm looking for when the output is 0, so the function is just going to be this equation here. And then we need to find the derivative, which is 3x squared minus 2. Now, x sub 1, the very first one, is going to be 2. So x sub 2 is going to equal to x sub 1 minus f of x sub 1 all over f prime of x sub 1, which will give me 2 minus f of 2 all over f prime of 2. Now this f of 2, which will give me 8 minus 4 minus 1. 8 minus 4 is 4, minus 1 is negative 1, all over f prime of 2, which is going to give me 4 times 3 is 12 minus 2, which is 10. So it will give me 2 plus 1 over 10, 21 tenths, right? Or 2.1. Okay. Now, in this case, I've just found x sub 2, and the next case I have to do is find x sub 3, which takes my previous output and now uses it as my input. And if you find the f of 2.1, let's plug in 2.1 into here and see what we get, which will get 0.061 all over 11.23. Calculate all of this out and it will give me approximately 2.0946. Okay. Now this one would be accurate to those 4 decimal places. Now let's talk about the graph real quick and that very first guess. So that very first guess here they gave to us. They gave to us to say x sub 1, which I did not write here, which x sub 1 was equal to 2. And they made us start from that point. Then we got x sub 2 was equal to 2.1, and we got closer and closer to that final x-intercept. Now if you take a look, let's take a look at the graph of x cubed minus 2x minus 5, which looks like this. So our initial guess, we started here at 2. We found the tangent line at that point, and then we approximated really close to that x-intercept, and then we used that to plug it in again. What if we started at x equals 0? What if the initial guess, without even looking at the graph, we decided to say x equals 0? Take a look at the tangent line that would have occurred at x equals 0. Now, what was Newton's method? Newton's method told us to find the x-intercept of that tangent line, which would have been somewhere way over here, and use that x-intercept as the input into my function. So what would be that f of x sub 1? It would shoot me all the way down to the bottom below here, which does not actually get me closer to my x-intercept. So it is very important for me to make that initial guess to be really close to that x-intercept, which is also why when you use your graphing calculator, it actually does iterations of the x-intercept of Newton's method. So when it asks you to guess where the x-intercept, it is so that it can give you an accurate one, especially if there's multiple x-intercepts. And that's it on Newton's method for today.